we want to apply the formula for calculating price elasticity of demand to solve the following equation. So here the question says we should prove that the price elasticity of demand PED of Q equal to AP exponent minus M is actually M. So what we are supposed to do is to go through the process of finding the elasticity of demand and see whether the elasticity of demand of this particular demand function will be equal to M. So the first thing we have to look at is how to calculate the price elasticity of demand. So here the price elasticity of demand is given by Q dq over dp multiplied by p over q, and let us name this equation 1. So having known this, we first need to find the dq dp, that is differentiating the demand function given in the question as q equal to ap exponent minus m with respect to p. Differentiating the demand function, you bring the exponent down and you subtract 1 from the exponent. Remember that a here is a parameter or a constant, and our variable of interest is p, and m also represents a parameter. So in doing that, we're going to bring the minus m down because a is already here, becomes minus ma, and we subtract 1 from the exponent. The qdp now gives me minus ma p exponent minus m minus 1, and we name this equation 2. So now that we've gotten the dq dp, which is the differential of the demand function with respect to p, let us substitute that which we have named equation 2 into the price elasticity of demand formula, which we have named equation 1. So when we do that, instead of the dq dp in the formula, we replace it by minus ma p exponent minus m minus 1. And remember that from the formula we already have p over q. So now our price elasticity of demand becomes minus ma p exponent minus m minus 1 multiplied by p over q. Let us name this equation 3. So all you need to do from here is to keep manipulating until you get your m. So remember that in our function, the q given to us in the function is ap exponent minus m. So what we need to do is to substitute that q equal to ap exponent minus m into equation 3. So instead of the q here, we are going to substitute a p exponent minus m. So when we do that, we're now going to have minus ma p exponent minus m minus 1 multiplied by p over, now it becomes a p exponent minus m. So now we continue with our manipulation. Now from here, you can see that p is exponent minus m minus 1. So we are going to use the laws of indices to separate the minus m from minus 1. And we know that when you are multiplying numbers of the same base, you add the exponent. So now we just go the reverse way. So now p exponent minus m minus 1 can be separated by multiplying p exponent minus m by p exponent minus 1, which does not change our equation. So from there, what are we supposed to do? You can see from here that because this and this are all multiplying, you can see that ap exponent minus m is the same as ap exponent minus m here. So the ap exponent minus m is going to cancel the ap exponent minus m here. So from here, you can see that this is going to cancel this, and I'll be left with minus m multiplied by P exponent minus 1 multiply by P. Now, when you look at this one, the P exponent minus 1 here is multiplying the P here, which is assumed to be exponent 1. So when you are multiplying numbers of the same base, you are going to add the power. So we're going to have minus M P exponent minus 1 plus my 1 here. So minus 1 plus 1 now gives me P exponent 0. And we know that any number that is raised to the power 0 equal to 1. So I'm going to have minus M P exponent 0. And because any number raised to the power 0 gives me 1, I'm going to have only minus M to be remaining here. But we know that when we find the elasticity of demand, we find the absolute value. So finding the absolute value of minus M, which we have gotten, gives us M. So we were able to prove that the price elasticity of demand of Q equal to AP exponent minus M is actually equal to M.